I've heard a little bit about your project, but and I understand it's based on a personal need of yours.
Yes. So we're trying to help low vision students take notes in class. The problem is that existing assistive technologies are basically optical magnifiers, but the problem with them is that you've got this great big board, and for a low vision student to see that board, he needs magnification. So he's going to look up, find that spot on the board, look down, write some notes, go back up, and there's a delay there as he cycles that fully sighted students won't have to deal with. And this was a delay that I encountered in 2007 when I added a math major to my computer science major, and that ended up requiring me to withdraw from some classes. So being a straight A student, that wasn't acceptable to me, so I was looking at other assistive technologies, and they all suffered from this board delay problem, or they suffered from this the requirement that there's building infrastructure or support personnel required. But in assistive technology, you can't expect those things to be available anywhere you go. So maybe your university can afford it, but what about that conference you're going to, or that company you're joining after you get out of academia? And so with that in mind, I sought out to design an assistive technology that not only I, but other low vision students could use and take with them to make their environments accessible according to their needs, anywhere they go. And so what we have here is a tablet PC. So this takes multi-touch inputs with your fingers, but it also, and very importantly, takes pin input, so you can handwrite your notes. So that pin input is subpixel accurate, so you can write math formulas very accurately. Attached to it is a pan-tilt zoom camera that we've designed. So this is our third generation prototype, but basically it's a camera with high zoom, 36x zoom. Under it are two servo motors that allow it to pan and tilt, so we can point it at arbitrary places in the classroom. So I'm going to point it over here out the window, and what's nice is you've got the split screen interface. Half the screen is the video, and the other half is the notes. So a low vision student might be looking at the screen 2 inches away, and much like a fully sighted student, he can quickly glance between the board and his notes. But of course you're still going to need to zoom in, and once you zoom in, you're going to need to be able to move the camera around. So we've made some very nice gesture-based control, enabled gesture-based control of the camera. So I can double tap any point and it'll center on that point. And I can also take my finger and, one second. So I can take my finger and drag any point, and whatever I drag will stay under my finger. So you have nice gesture-based control of the camera. We can zoom in with another gesture here, as you can see there. So we're zooming in on license plates from the 20th floor yesterday. We don't have any good scenery here today. But you see this nice gesture-based control. Another nice feature that we have is that the professor will often get in the way of the notes that he's writing on the board. And so what we can do there is, if you'll permit my hand to be a professor, the professor gets in the way, and we can, let me do that again. The professor gets in the way, and we can go back in time to before the professor was in the way. And now, once we're done taking our notes, we can go back to the live video, and here we are.
So this is the ultimate in meeting a need, because it was your own need.
It was my own need, but of course one one data point cannot represent a whole population, and in fact the low vision population and I think disabled population more generally have very diverse needs, and so we've been engaging other low vision students. So we built this first generation prototype here a couple of years ago. This is what I used initially, very ugly. Parts of it came from Walmart, in fact, but it got the job done. We had another low vision student using it for a month and had very good feedback. So then, following that, we built the second generation prototype, which was using industrial parts. We had another half dozen low vision users using that, and they gave us great feedback on how to make it more usable. But all of them said, even despite its shortcomings, they all said that they would love to, they need one of these in their classwork. And so that prompted us to figure out the design decisions for this third generation prototype, which we've designed here. So the shell was printed with 3D printing, so it's stereolithography. We have all industrial components inside there, so it's very precise and very responsive and aesthetic enough that when we show it as a product concept, people can we hope that people can understand that this product is actually solving the needs of low vision students.
When might people be able to just buy this off the shelf? Are you thinking of productizing it?
We are. So there's about 20 million low vision students in the U.S. Adults, in the U.S. And so we're talking about spinning off a company, and the strategy wouldn't be to sell to these low vision individuals directly. privately, but to actually become a vendor and develop good relationships with state-based vocational rehabilitation agencies who provide assistive technologies for individuals that need it. And we hope that by doing this, we can correct the appalling figure which is that less than 40% of low vision adults participate in the workforce. And we think that the inaccessibility of education is in large part to blame for that.
Well, thank you very much for showing it to us.
Yes, thank you.
Good luck in the competition.
Thanks.
Yep.